Hi, I'm Richard Mobbs, and this is mathematical tutorial number 3 for the Open University course TU100, and this is going to be looking at dealing with large numbers. All of my resources can be found at the following website. Dealing with big numbers. Well, let's start with something reasonably small for the time being, and we talk about the thing called the kilo. Now, we're used to this in terms of kilograms, which is 1,000 grams, a kilometre, which is 1,000 meters, or a kilowatt, which is 1,000 watts. We use the letter K, the small letter K, as a shorthand notation for 1,000. Note it is a lowercase k for kilo. As technologists, we have to get used to dealing with large numbers, and we increase our numbers by multiplying by 1,000. This is often called engineering notation. So what do we get when we multiply a kilo by 1,000? The answer is 1,000,000, one with 6 zeros after it. This can be abbreviated to the letter M, sometimes called mega. For example, 1M is 1,000,000. What do we get if we multiply a mega, a million, by 1,000? Well, the answer is 1,000 million, which we call a billion. But we don't use a billion within technology. We call this a giga. And this is abbreviated to the letter G, capital G. For example, 1G is 1 followed by 9 zeros. We're beginning to get a large number of zeros, perhaps too many of them, and this looks ugly on the page, and often mistakes happen when we try to write them all down and trying to keep track of them. So we use a shorthand notation using the powers of 10 to represent those zeros. 1,000 is 10 times 10 times 10, and we can represent this as a product of tens, as representing it as 10 to the power of 3, showing that 10 has been multiplied by itself 3 times. We say 10 to the power of 3. A kilo multiplied by 1,000 is our mega, 1 followed by 6 zeros, which is 10 times 10 times 10 times 10 times 10 times 10 6 times. So we write it as 10 to the power of 6. We say 10 to the power of 6 represents our million or our mega. Sometimes you might meet other terminologies. We are saying to the power of 6, but in actual fact sometimes you might meet it as being referred to as the exponent or the index. Basically, index, powers or exponents, they're all the same thing. And we always say things like raised to the power of or the exponent of. They all mean the same thing. Just a slight mathematical aside, 10 is 10 by itself, so 10 to the 1. 100 is 10 times 10, so 10 to the 2. And 1,000, as we've seen, is 10 to the power of 3. What does 10 to the power of 0 represent? And mathematically, by convention, any number raised to the power of 0, we represent that by the number 1. So we can see a pattern. Every time we multiply by 1,000, we'll keep adding 3 to the power of 10. So we start off with 1,000, which is 10 to the power of 3, a million is 10 to the power of 6, and we've just seen a giga was 10 to the power of 9. Basically, whenever we look at a large number, it can always be represented by 10 to the power of count the number of zeros. So if I have a number here, and I want to represent it to the power of 10, all I do is to add a decimal point on the end and then start moving the decimal point to the left. And every time I move it one place to the left, I add 1 to the power of 10. And in this particular case, I move my decimal place 9 times, so my answer is 10 to the power of 9. We are basically following a simple rule. If we've got a large number and we want to represent it in a power of 10, we move the decimal point to the left and we add 1 to the power of 10 until we arrive at a single significant figure. That's a number between 1 and including 9, and the decimal point. Additional numbers become decimal places. For example, if I had a number like 2,456,390, this can be written as 2.4569390 times 10 to the power of 6, since we have moved the decimal point 6 places to the left. How big can we get? Well, we can just keep adding powers of 10 up to very, very large numbers. So we looked at 10 to the 3, 10 to the 6, 10 to the 9. Our next one is a trillion, which in technology terms we call a tetra. And we can go with 10 to the 15, which is petra, and 10 to the 18, which is exa. These are large storage capacities, which we will meet on the course. Once again, my resources are available at the following website, and I hope you enjoy these tutorials.